Welcome back to WOW TV. Today we'd like to present to you our Magnets 1 demo. This lesson is best used for primary students. We assume all children have played with magnets at some point in time, but this will allow them to begin to understand why magnets react the way they do and what that has to do with the world around them. This is a great introduction and an opportunity to see different magnets in action. When a wizard brings our magnets kit, or if you borrow it, like you can with all of our kits through WOW on Wheels, these are the materials included. There'll be 2 different magnets, one being a little stronger than the other, paper clips, 2 donut magnets for each student to use, a pencil for each student to use, wand magnets, cases of iron filings, baggies for each student, and in each baggie, hold on, the magnets are working. And in each baggie, a donut magnet hanging on a piece of dental floss. There will be compasses included, a copper pipe, and a plastic pipe. Review with the students what is a magnet. Ask them to define it, ask them how magnets work when they've used them. Talk about a magnetic force and a magnetic field. Explain to students that that magnetic field is invisible, but it is what is doing the work for the magnet. Talk about the magnetic field producing the force that attracts the other objects. Use the words attract and repel, and talk to students about what those words mean. We also want to mention to students that gravity, like magnetism, is a force, and that gravity attracts. But unlike magnets, gravity affects all objects. Magnetism is different than gravity because only some types of materials can be magnetized, so they use that magnetic force, and some materials are affected by that force, like iron and nickel. Magnets come in many shapes and sizes and can be made from different materials, but only metals are magnetic. We move into student activity number 1. Ask the students what happens when 2 different people are on opposite sides of that wagon trying to pull in their direction. Maybe even have the students act it out in the classroom by using a table or a desk. Now imagine that the 2 kids realize it's not working and they switch positions, and they both pull or push from the same side. The wagon moves. What does this have to do with magnetism? Everything around us is made up of tiny particles, and one of those particles is the electron. These electrons are tiny and we can't see them, but as the name suggests, electrons have an electrical charge. And when electricity moves, this magnetic field is created. So if electrons are in everything and they're magnetic, why are only some materials magnetic and others aren't? Why isn't my dog magnetic? Think back to the example of the students pulling the wagon. In some things, the electrons send their magnetic pull in different directions. If you're pulling on something from all different directions, it's not going to move. In metals that are magnetic, the electrons are all facing the same way. So when they all pull in the same direction, things will move. Let's move on to student activity number 2, asking the students which materials are magnetic. Show the students the 2 different magnets that we have and explain that some magnets are stronger than others. You can test 2 different types of magnets by showing which one will hold more paper clips. Ask the students to make a hypothesis, maybe even a number of paper clips it would hold. We know that not all materials are magnetic. If I use something like the pencil, I'm not making that attraction at all. Start with the weaker magnet, and let's see how many paper clips we pick up. There's about 6 or 7 in there. And our stronger magnet, I'm not going to count them. So obviously our students can see that magnets have different strengths. And of course, compared to other materials that aren't magnetic at all. We want you to then give the students each a wand magnet. Challenge them to find 3 materials in the room that are magnetic and 1 that isn't. And the bigger challenge is, can they find something different than their classmates do? In the next activity, give students 2 donut magnets. Let them begin to experiment and see if they can feel that force, feel that pull. Talk again about attracting and repelling. When you're ready, give the students the pencil to use and allow them to begin experimenting. Of course, we always recommend only give the students the materials when you're ready for them to use them, because as we know, they're probably not going to wait. All right, so we're going to put these on here and let them experiment. Do some magnets just not like each other? Maybe they're not friends. Have you ever heard of the saying opposites attract? Well, of course, this is true for magnets as well. This is a great way to reinforce with the students attracting and repelling. Discuss with students that iron is a magnetic material. They have the donut magnets at their desk. You might want to move the pencils out of the way and then pass out the iron filings and allow the students to begin to experiment. Let me get one of these. Ask the students, did you know that the planet Earth is a big magnet? The Earth produces its own magnetic field. This is because the Earth's core is mainly made up of iron, one of the best materials for making magnets. And part of the Earth's core is continuously spinning really fast, which creates a magnetic field and is the reason why the Earth has a north and a south pole. This is helpful for explorers and adventurers as they can use a compass to find out which way is north and which way is south. As you explain that to students, you bring out your compasses. There will be enough for students to share. We suggest that you use one first to show what you're going to talk about and then let the students experiment with it. Talk a little bit about what is a compass and how hikers may use them when getting lost, how sailors may use them to find direction. And as you probably already know, a compass works by showing where north is. Once you know where that is, you can figure out where south, east, and west are as well. Why does the compass needle always turn to the north? And how does it know? Magnets, of course. The compass needle itself is a magnet. And what other magnet is it being attracted to? The Earth. The Earth itself is a very weak magnet with its north pole at the North Pole and its south pole at the South Pole. So the compass needle is attracted to the North Pole and will move towards it. Go ahead and demonstrate this for the students. Give each student a baggie, and in that baggie will be a donut magnet tied to a piece of dental floss. When holding the string in the air, the magnet should turn to face the north. And if students move, the magnet should adjust. For the last activity for the students, show the two pipes that we're going to be using, one copper, one plastic, discuss what they're made of, and ask the students if they think they're magnetic. Ask them to predict how quickly magnets will fall through these pipes. We're going to use the plastic one first. Use the stronger of the two small magnets that you've been using during the demo. Start with the plastic pipe. They've predicted how long this should take. Have them count with you as it drops. Let's do that one again, just so they can see how quickly this happens. And then switch to the copper pipe. Again, they're going to predict how quickly this will fall through. They've told me it's not magnetic. They're oohing and awing. They think it's stuck. You could even show them that it is hollow through the pipe. Obviously, it took a lot longer to fall through. They're going to want to see it several times, I promise. And discuss that the magnet slowly and temporarily magnetizes as it falls through the copper pipe, slowing things down. So to end our magnets demo, do a quick review of what they've learned about force and about magnetic fields, about gravity, what is magnetic and what isn't. Thanks.